All right, so yeah, pretty intense day. So we have been talking about all the technical details, the infrastructure and the theories. So I probably can just wrap up everything by a very use case focusing lightning talk. So yeah, all those are valuable. Decentralized AI, TEE, verification, those stuff. But I will try to keep it as simple as possible, and I'm not going to focus too much about the vision or too much about the technical, but just a little bit to share my idea, and I will also want to hear the feedback from everyone here. So by the way, I'm Hang from Fala Network, and I'm the technical guy in CTO. And today we're going to talk about decentralized AI. So maybe first thing first, why we would even need a decentralized AI? That didn't mean we're going to produce the proof for every model output and verify that by the end user. If I at least for me as an end user of ChatGPT, I care less about the output of ChatGPT. It works pretty well, so I will not verify any signature from OpenAI. But it actually works. It actually makes sense. And apparently, those are the things we have been talking about for a long time. So I'm not going to repeat it. AI is centralized now, so I'm just going to skip this page. And but how is AI being centralized? So basically, there is a self-enhancing loop. First of all, most of the big large language models are created by some central companies because they own the data, right? And they build the private AI models. And since the private AI models are using the best data set they have trained, so they have the best performance. And people are going to use the best model, right? So that's why they can make a huge amount of money. And to make it worse, when people are using their model, they also generate the data for the centralized company. So this is if we have no way to break it, then we can foresee no AI will be open source or decentralized. But is it possible to break this one? And I do think there are some possibilities. If we can have, say, better decentralized AI, then probably we can get users starting to use that. And this actually makes a little bit sense because apparently, I think the quality of the model is determined by the quality of the training data. And I think although I'm not a part of OpenAI, but I believe they have already exhausted all their training data because they have scrapped all the data they can from all over the world. So that's why they have GPT-4, GPT-4o, but never GPT-5, right? So if say we can somehow build a better model, then probably we can if we can build a better model, then maybe majority of the users are going to use this model. It's going to generate revenue, and once we get revenue from the best model, then we can actually incentivize people to provide their data for training. Say OpenAI has all the public data, but even more data, your data, my data, is not a part of OpenAI's data. If we combine all those data together, theoretically, we can have an even larger training data set. So that's why if we can combine all user-owned data, it will be way more than any company-owned data. Then we have the better decentralized AI, and we have majority of the users switch to the decentralized AI instead of the centralized AI. So this is the assumption of the strategy. So in this case, we can have individuals, companies contribute their data, maybe 1%, 2%, just write some random number, and we mix them together as a big training data set. And then we can train the AI models, and we can use the model by the buyers, and they get the revenue, and we share the revenue all the back to all the contributors. But in this process, the interesting thing is, what are we missing? Probably we already have some kind of data protocol. A bunch of them are working on getting data from individual users. but it's not useful right now because we do need two things to make everything work. One is verifiability, and another is confidentiality of all the computation here. So basically, this diagram is the supply chain of the AI model, and within this supply chain, everything must be verified. Because why? Because we want to make sure as long as you contribute, you're always going to get the right amount of the reward from the final model revenue, right? So it should be verified, both in building the training set and training the model and serving. On the other side, the problem is even harder than something ZK ML can solve. Not talking about the performance overhead, but ZK ML cannot solve the confidentiality problem. Here, we are going to mix the data set from different individuals together, and then we're going to train the model with their data. So if we're going to use some kind of just the verifiability, I'm not going to share my user data with you, and you're not going to share it with me. How can we find somewhere we both trust to train the AI model? This is where this is why this is become even more complex. We need confidentiality. So yeah, combine those requirements together. This is basically what we need. Some kind of communication protocol with verifiability and reality. So far it's all the basic idea, and of course this is super hard. I'm not saying we can actually make this happen maybe within a few months or even this year. There's no existing technology to train a super large machine learning model with verifiability and confidentiality. And there's no single company can use both the data collection, the training, serving, all those parts. So yeah, I think this will be a long-term effort. But we do see the hope. The hope is now we have GPU TEE. So yeah, I believe so far the only GPU with TEE enabled is H100. It was just launched last year, and maybe next year there will be launched B100, which will be more powerful. But how does it work? It's basically as a user, you can send arbitrary input to H100 TEE, and within the TEE is basically some environment where you can run any program you can deploy with a normal H100. You don't need to change any code. For example, it can be pure torch and string, and you run the model, give the output with some kind of proof, remote attestation or some other kind of attestation. Then you can verify that by the end user or even on the blockchain. And to break it down a little bit, actually the H100 TEE, it doesn't work just standalone. It must be work with TEE CPU TEE. So how does it work with this? On the one side, we have the GPU. On the other side, we have the CPU TEE. Usually it's Intel TEX or AMD SCV. We deploy so basically it's not like Intel SGX. It's a confidential virtual machine. And in the confidential virtual machine, you have a whole operating system. You have the NVIDIA driver. So the driver is even running in TEE mode. The driver will go to bootstrap the TEE GPU, and there should be some kind of verification between the driver and the TEE to make sure there's no anything wrong in between them. Then we load the program into the CPU TEE just like a simple Unix program. It will interact with the NVIDIA driver and interact with the TEE GPU. And the driver itself actually creates a kind of two-way end-to-end encrypted channel between your program and the GPU. So that's how everything combines together. Of course, we verify the attestation. How does the attestation work? So on the GPU side, NVIDIA has the GPU attestation, and it's going to measure the GPU firmware, the hardware, and also the program you deploy to GPU. And on the CPU side, people are already familiar with that. We can have the the TDX or SCB attestation, and then Intel endorse this one, Intel endorse this one, NVIDIA endorse this one, and the CPU attestation has the reference to the GPU attestation. So you can have the channel trust from Intel, NVIDIA to the program you're running on the inside now. So yeah, this is basically how that. But of course, there are a lot of limitations. Like now, there's only it only supports one single server GPU setup. Like you cannot have thousands of GPU connected together to train some real interesting stuff. But I think it's already possible to train something like fine-tune Llama 3 in a single GPU or a cluster of 8 GPUs together on this machine, and of course do the inference. And how about the overhead? So unlike the ZKML or any other cryptography-based solution, so this is a simple diagram I got from some other white papers. Left side is computational computing not enabled, right side is enabled. So if you really measure, it's around 3 to 5% overhead. So yeah, pretty seamless. So the left one is for inference, the right one is for training. The bottleneck of enabled TEE GPU is actually the bandwidth between the CPU and the GPU. So when doing the training, then there are a lot of data exchange between the CPU and the GPU. That's why if you enable individual computing, there will overhead of around 5%. But it heavily depends on the real use case. How large is the model and how the structure is the model is. So yeah, that's basically the background. And there are some challenges, but I think before digging into the challenges, I'm going to show you a simple demo. So here, yeah, actually this is not like a live demo. It's more like a video record. So we make a very simple demo. We got some 160 records. These two files. So here we actually create some kind of NVIDIA remote classification from the hardware, and we can copy it and then verify it with the NVIDIA extract. So they have the past the GPU data. We just paste it here and get the verification results. So yeah, this is how it works. Yeah, I'm not sure what it is. And then we run Llama 3, so I can just ask them some simple questions. And here we actually make it very easy to be verified by having the EVMP this time. So we sign the output. So you can copy back the output and plus the signature and verify it. Very simple. And then we also have these, it will be permission errors. So now we already have a documentation, but to be honest, I haven't really fully copied. But here you can check how it will look like. So basically, we provide the confidential inference interface. There will be an endpoint. It's like semi-decentralized because we don't have to build a decentralized network of zero. It's still just a few nodes from our side. But we can make sure it's already protected by the TEE. So it's kind of okay to trust it to some extent. So here, what we offer is a set of API. So you can request the remote attestation report from the server, and it will give you the NVIDIA results, the signing. It will be like establish a channel of trust. But in this example, it's still missing the TDX remote attestation. and yeah, you can verify that with NVIDIA API. And we have the chat API, pretty similar to those like very simple Llama API. You can call that to chat. And eventually we're going to have some signature embedded in the response. So in an HTTP response, so that you can use the response, the signature in the response to verify the content in the response of the HTTP payload.
In the demo you showed, you only verify the signature of the output.
Yeah.
How do you find the output to the actual model?
Yeah. That's
missing, right?
Yeah. That's a right. That's a very good question. So in that demo, is actually very simple. We just show this is something we can do. But of course, here what we're going to do is in the signature, it will commit to all the input and output. And in the input, it will look like, let me check. Okay, it will look like something like this. You can see there will be the model here, and I think eventually we're going to allow people to load like arbitrary model available on Hugging Face. So you have the Hugging Face ID here, and this is the inputs. Then the outputs, all of them will be combined and decided. So yeah, this the demo. Any question on the demo?
Was there any hard thing in getting on good attestation for it, or was this fairly easy to work with?
Well, I think eventually it should be pretty easy because once we have everything already set up, then what we need to do is just to create like an image, and in the image we can include our software to load the model, and pretty similar to the development outside of the TEE. But the problem is there are two things. One is how can we get the drive? Well, it's super expensive, but to make it worse, like in my understanding, but I haven't tried. In my understanding, if you buy something, it has the capability of the TE, but you need to enable that with the approval from NVIDIA. So, like you're going to make a phone call.
Is it a subscription, or is it like?
Well, it's a free subscription. So basically, they are going to ask you, why are you going to use it? And if you give the right answer, the good answer, they're going to install that for you.